video, I'm going to go over addition reactions, what they are and how they happen. So addition reactions are a specific type of organic reaction that involve the reactant having a double bond or possibly a triple bond.
So this has a double bond here, we can see. Now what this double bond does is it's going to react with the water molecule. See here? Now what happens is the double bond breaks like this, and the water molecule breaks like this. We have an OH and we have an H, and then the H joins to there and the OH joins to there, and we now have an alcohol molecule.
Now the reason that alkenes that have double bonds can undergo addition reactions is that the double bond will break and then it will form two new attachments, and because we're adding two new atoms or groups to it, it's called addition because we're adding. Now every time that we do a specific type of addition reaction, we're going to have an associated reagent, and you can see that I've got 5 different addition reactions shown here in this table. Hydrogenation, halogenation, 2 different types of halogenation here, hydration and addition polymerization. But let's have a look at each one of these examples. So in the hydrogenation, we're going to start with an alkene and we're going to have as a product an alkane. And so what happens here is, here's an alkene, this is pent-1-ene. We're going to add the reagent, which is hydrogen gas. Now there are 2 versions of reagent we can use here, and we have to be familiar with. The first, so remember we need a double bond, and the reagent is hydrogen with platinum, or it could be hydrogen with nickel over here. Now, if we break this double bond here, what's going to happen is we are going to join on the second carbon and the first carbon, and what we're adding to this are hydrogens. That's what the H2 is. Now whenever we write the reagent and we put H2 and then /PT, the thing on the left hand side of the / is what we're actually adding, and the thing on the right hand side is the catalyst. So we're adding hydrogens and H2, which means we're going to add a hydrogen to each place where the double bond is, and then we end up with this molecule, which is going to be an alkane. Actually in this case it's pentane. So this is hydrogenation because we're adding hydrogens to the carbons that were part of the double bond. The next one is called halogenation. So in this case, in halogenation, we're going to add halogens. Now the first example I'm going to give you is we add a diatomic molecule of halogens, or 2 halogens joined together in a molecule, and we either use chlorine, bromine or fluorine. They'll write whatever halogen is above the arrow. Remember again, the double bond is going to break at the point the double bond is going to break between the 2 carbons, and that's where we're going to attach them. Now we don't have a catalyst with the bromine, they're quite reactive, so it will break this double bond and we will add 1 bromine atom each to where the double bond was broken, and there we get. And here we get a haloalkane, and of course this is going to be called 2,3-dibromobutane. Okay, so the next type of way that we can carry out a halogenation is we can add hydrogen chloride, hydrogen bromide, or hydrogen fluoride. So that is a molecule that has a hydrogen and a halogen attached. In this case, we're using hydrogen fluoride. So if we break this double bond, of course, we have 2 atoms available to attach, a hydrogen and a fluorine. And so we add the hydrogen and we add the fluorine. Now actually sometimes we have an issue when we break the bond. If the organic molecule, sorry, the alkene is asymmetric, we have to decide what side we put the fluorine and what side we put the hydrogen. And in fact, in a later video, we're going to learn about Markovnikov's rule that explains how we identify which one will happen. So that's the 2 types of halogen reactions. The next one is called a hydration reaction. So we're adding water okay, to the molecule. And in fact, when we use a reagent to add water, it actually has to be in acidic condition. So we add H2O/H+. So you can either write that as the reagent, or you can write dilute H2SO4, or sometimes H2SO4 brackets aqueous. In this example that I'm giving you here, I've got H2O with the dilute acid as the catalyst. Now remember, it's the thing on the left hand side of the / that we're adding, and what we have here is an H and an OH that has been added. Okay, so if you could split the H2O molecule in two, however you break it, it's always going to break into a hydrogen and an OH. So we add a hydrogen to one side and an OH to the other, to the double bond once we've broken it. So here we have now produced an alcohol molecule, right? Now, interestingly, most of the time the OH will attach to the middle carbon here. And remember, there's a rule as to why it does this, and this is called Markovnikov's rule, but we'll learn this later. And the last one is called an addition polymerization. Now, addition polymerization is when we take a large number of alkenes and we break the double bond, and then what happens is we join them all together in a long chain. So here, if we break the double bond, we would join it together where the double bond was broken, exactly the same way as we did in the others, but we would form a long chain when it's under heat and it has a catalyst. So the long chain we form here is, the wee squiggly line means that it is a chain that continues on for hundreds of atoms. Okay, so it's not the end of the chain, it just continues, and I'm just showing so many of these units repeating here. And those are the different types of addition reactions we have to be able to do at this level: hydrogenation, halogenation, hydration, and addition polymerization. Now, when you have to justify and say what type of reaction is happening, you can just say each one of these is an addition reaction. And remember, addition reactions have double bonds, the double bonds break, and the atoms or groups attached to the carbons where the double bond had broken. Hey, thanks for watching this video. Hopefully this has made you more confident with your chemistry. Don't forget to like, subscribe, or leave a comment about anything that you want to with this video or any questions you have. I'll see you later.